My name is Eshan Saraf, and I am going to explain this PPT which I have made on the topic of applications of timer. This is my photo as asked by you, ma'am. My name is Eshan Saraf, roll number 050, and I'm going to speak on topic application of 555 timer. It is submitted to Dr. Kamaldeep Kaur, Assistant Professor GGS IPO and our STLD teacher. What is 555 timer? As I've written, 555 timer is a monolithic timer integrated circuit. Integrated circuit or monolithic integrated circuit, you can call them like any one of them, is a set of electronic circuits on one small flat piece of semiconductor material that is normally silicon. It is one of the most popular and versatile sequential logic design which can be used in both monostable and astable modes. The basic building blocks of 555 timer are RS flip-flop, two comparators, reference voltage source and discharge transistor. RS flip-flop. What exactly is a flip-flop? A flip-flop is a bistable device. There are three different classes of flip-flops: latches, pulse triggered and edge triggered flip-flops. We're not going to study in detail about these flip-flop because our only topic is application of timer, and all these are just the basic intro. Similarly, comparators, it is a device that is used to compare two voltages or currents, and it outputs a digital which indicates which is larger, which one of them is larger. It has two analog input signals and one binary digital output. Reference voltage source. It is an electronic device that ideally produces a fixed voltage irrespective of the loading on the device, power supply variations, temperature changes, and passage of time. Then we have discharge transistor. As the name suggests, discharge, it is used to discharge a timing capacitor. When the voltage reaches 2/3, the supply voltage set by comparator 1 governed by 3 into 5K resistors in the potential divider. These four are the building basic blocks of 555 timer, and each and every timer consists of these. Each and every 555 timer consists of these. Then now I am going to this is a block diagram of 555 timer which I am going to explain. Okay, so as you can look at the diagram, it has two comparators which are basically two op-amps, two operational amplifiers, one RS flip-flop, two transistors, and a resistive network. Resistive network consists of three equal resistors as shown, and it acts as a voltage divider. Comparator 1 compares threshold voltage with reference voltage 2,3 VC, and comparator 2 compares the trigger voltage with reference voltage 1/3 VCC volts, as you can see in the figure. Output of both the comparators is supplied to the flip-flop. Flip-flop assumes its states according to the output of the two comparators. One of the two transistors is a discharge transistor, of which collector is connected to pin 7. This transistor saturates or cuts off according to the output state of the flip-flop. The saturated transistor provides a discharge path to a capacitor that is connected externally. Base of another transistor is connected to a reset terminal. A pulse applied to this terminal resets the whole timer irrespective of any output. This was the explanation of how a 555 timer block diagram works. Now, application of 555 timer. When we study 555 timer, we find there are two applications of 555 timer. These are, one is monostable multivibrator and the other is astable multivibrator, which we will study later in this PPT. Okay, so first to start with monostable multivibrator. As name suggests, it is a pulse generator circuit in which duration of pulse is determined by RC network connected externally to the 555 timer. In such a vibrator, one state of output is stable while the other state is quasi-stable, which is another name for unstable. For auto-triggering of output from unstable state to stable state, energy is stored by an externally connected capacitor C, which we take as C, to a reference level. The time taken in storage determines the pulse width. The transition of output from stable state to unstable state is accompanied by external triggering. The schematics of a 555 timer in monostable mode of operation is shown in figure, which I will show in the next slide. The best way to explain a monostable multivibrator is by explaining it using its diagram. Okay, as we can look at the diagram, pin 1 is grounded. See, trigger input is applied to pin 2. In quiescent condition of output, this input is kept at VCC, as you can see. To obtain transition of output from stable state to unstable state, a negative going pulse of narrow width, that is a width smaller than expected pulse width of output waveform, an amplitude that is greater than this 2/3 VCC, is applied to pin 2. This pin here, pin 2. Okay, output is taken from pin 3. Pin 4 is usually connected to VCC, as you can see in the figure, to avoid accidental reset. Now pin 5 is grounded through a 0.01 farad capacitance here. This capacitance, as I expand the screen, this capacitance. Then pin 6 is shorted to pin 7. Here it is shorted to pin 7, and at pin 7 a discharge capacitor is connected, while pin 8 is connected to supply VCC. Also you can see a resistor RA which is connected between pins 6 and 8. Okay, so this is how we can explain the diagram of monostable multivibrator. We can also explain the operation, however it will be way too big. However, I will just explain it will summarize in some few words. So the operation of the circuit, I will explain the operation. I will explain the operation of the circuit. Okay, so initially when the output at pin 3 is low, that is, the circuit is in a stable state, the transistor is on, and the capacitor C is shorted to ground, as you can see. When a negative pulse is applied to pin 2, this pin, the trigger input falls below 1/3 VCC. The output or comparator goes high, which resets the flip-flop, and consequently the transistor turns off and the output at pin 3 goes high. Now, this is a transition of output from stable to unstable state, as you can see in the figure. However, as the discharge transistor is cut off, the capacitor C begins charging towards VCC through resistance RA, which is between 6 and 8 pin, with a time constant equal to RA into C. When the increasing capacitor voltage becomes slightly greater than 2/3 VCC, the output of comparator 1 goes high, which sets the flip-flop. Now the transistor goes to saturation, thereby discharging the capacitor C, and the output of the timer goes low, as you can see in the figure. Thus the output returns to stable state from the unstable state. This is how in this figure the output went from stable to unstable state, and eventually it came back from unstable to stable state. This is how a monostable multivibrator works as a 555 timer. Now the second application of a 555 timer is just a second. Astable multivibrator. An astable multivibrator is an oscillator circuit that continuously produces rectangular wave without the help of any external triggering. Now, astable multivibrator is also known as free-running multivibrator. It is another name of astable multivibrator. So, using 555 timer, astable vibrator becomes very simple, easy to design, very easy and low cost. And it is very cheap. However, when we use 555 timer in astable multivibrator, the timing used in astable multivibrator can go from microseconds to even hours. Okay, next slide. It has no stable states and continuously switches between two states without application of any external trigger. The integrated circuit 555 can be used as an astable multivibrator with the addition of 3 external components, that are 2 resistors and a capacitor, as I will show you in the figure in the next slide. Due to these reasons, 555 timer has a large number of applications. It is a popular integrated circuit among electronic hobbyists. Now I will show you this diagram. Okay, so in this slide I will explain you how astable multivibrator works using 555 timer. Okay, as you can see, the circuit of a just a second. 8 pin and first pin of the integrated circuit are used to give power. As you can see, 8 pin and first pin to give power, VCC and GND respectively. The fourth pin is the reset pin, which is active low and is connected to VCC to avoid accidental resets. Fifth pin is a control voltage pin which is not used. So to avoid high frequency noises, it is connected to a capacitor C, as you can see here. As you can see here, as I will expand this slide. See, it is connected to a capacitor which is connected to the ground here, this ground. Okay, so usually the resistance of the capacitor is around 0.01 microfarad. The trigger, that is pin 2, and the threshold, which is pin 6, inputs are connected to the capacitor, which determine the output of the timer. Discharge pin, which is pin number 7, is connected to the resistor RB. Here discharge is connected to the RB in such a way such that the capacitor can discharge through RB. See, the 7 is connected. This 7 is connected to RB so that RB can discharge. Such that this capacitor can discharge through RB. Now we see a diode D. This diode is named as D. It is connected in parallel to RB, and it is only used when an output of duty cycle less than or equal to 50% is required. So only when the output of 50%, less than 50%, or 50% is required, only then we use this diode. Okay, so this is the explanation and the importance of all the parts. Now I will explain. Not exactly, I will just summarize the working of this diagram of Astable Multivibrator using 555 timer. When the circuit is switched on, the capacitor voltage will be less than 1/3 VCC. So the output of the lower comparator will be high and of the higher comparator will be low. This sets the output of the SR flip-flop. Thus the discharging transistor will be off and the capacitor C starts discharging from VCC through resistor RA and RB. Thus the discharging transistor will be off and the capacitor C starts charging from VCC through resistor RA and RB. When the capacitor voltage will become greater than 1/3 VCC, the output of both comparators will be low and the output of SR flip-flop will be same as the previous condition. Thus the capacitor continues to charge. When the capacitor voltage will become greater than 2/3 VCC, the output of the higher comparator will be high and lower comparator will be low, as I have just told above. This resets the SR flip-flop. Thus the discharging transistor turns on and the capacitor starts discharging through resistor RB now. Soon the capacitor voltage will be less than 2/3 VCC and the output of both comparators become low. So the output of the SR flip-flop will be in the previous state again. So the discharging of the capacitor continues. Earlier the charging continued, now the discharging continues. When the capacitor voltage will become less than 1/3 VCC, the output sets since the output of lower comparator is high and higher comparator is low, and thus the comparator starts charging again. Thus this process continues and the rectangular wave will be obtained at the output. So you see, in this, as you can see initially, when we press the on switch, the output of lower comparator will be high and the output of higher comparator will be low. Then there comes a stage where the output of lower comparator becomes low and the output of higher comparator becomes high. And after going through a rectangular wave, it again comes back to the starting where the output of lower comparator becomes high and the higher comparator becomes low. So by using this, I have explained the block diagram of the Astable Multivibrator. So these are the applications of 555 timer, which I have explained using this PPT. Thank you. However, also I would like to say the reference I used was Modern Digital Electronics as told by Kamaldeep ma'am, which is written by Sir R.P. Jain, and electrosome.com and electronicshub.org. I use this to get some idea, a better understanding of the topics which I was going to explain in this PPT. Thank you, ma'am, for listening.